Alright, so let's start implementing our blockchain. Here we will create a Flux-based web application to interact with our blockchain by making requests on Thunder Client. Thunder Client is a lightweight REST API client extension for VS Code. Let's get the Thunder Client first. For that, go to the extensions and search for Thunder Client. And install it. You can also use Postman for this, but we need to install Postman separately. So why we borrow that if VS Code is giving this feature? Why not use it just by installing the extension? Alright, Thunder Client is installed. You can see it around here. Now let's create a Flux-based web app. For that, we will follow the Flux documentation and the quick start. If you see here, we have already imported Flux. Then let's copy the second line and paste here. After that, there is a route which we will come in a bit. First, let's create an instance of our blockchain class that we have created above. Blockchain equal to blockchain class. Now for route, we will need 3 routes. One for mining block, second for getting chain, and third for checking if the chain is valid or not. Let's start with the first route, mine block. If you follow the quick start, we have to use the route decorator to tell Flux which URL should trigger our function. For mine block, I will specify URL as mine_block after the slash. Then we also need to add another argument, which is the method of the request, and this request is gonna be HTTP method. For this, we also have documentation HTTP methods. Here you can find all the information of different requests you can use in the Flux to perform some actions. So for mine block, we need get request, because difference between get and post is get only gets you something while post will create you something. We will use post method in section 2 while creating some transactions. For now, we will use the get method as we just need to get the block by mining it. Let's add this method in the parameter, and we will only add the get method. Alright, so now we are ready to implement this mine block function. Let's create the mine block function. It won't take any arguments since we will get all the information from the instance blockchain of blockchain class. Now let's define what this function do. We need to mine the block here, and how do we mine the block? Well, we first need to solve the proof of work problem and find the proof. Once we get the proof, then we can create a block by getting other keys. They are index, timestamp, and previous hash. Okay, so let's get this proof. In order to get the proof, we will apply this proof of work function, and you see in order to apply proof of work function, we need the previous proof. And for getting previous proof, we have the get previous block where we can get previous proof. So first, let's get the previous block, which we can get by using the class instance blockchain and call the get previous block function. Now we can get the proof of this previous block, which will be previous proof by previous block and taking the proof key of the previous block. This will give us exactly the previous proof we are looking for. Now since we have the previous proof, let's call the proof of work function. Let's get the proof by calling the proof of work function and pass the previous proof that we just got as the parameter. So we got the proof now. Let's get other keys to create a block. If you see create block function, we need 2 things here to call this function, proof and previous hash. We have the proof, now let's get the previous hash. And for getting the previous hash, we will use the hash function which takes block as the argument. So for getting the hash of the previous block, that is previous hash, we will pass the previous block here, which will give us the hash of the previous block, and this is our previous hash. Alright, so now we have both the proof and the previous hash. Let's create the block now. Block equal to blockchain object and call the create block function and pass the proof and previous hash as the parameter. This create block function not only creates block but also append that block to the chain and returns that block. So let's display it in our Thunder Client. For that, let's create a response variable which will contain all the information of the block, and as well as we will display a nice message as congratulations, you just mined a block. So this will be the format of the response. Now we need to return this response so we can display it. We will not directly return this response, we will JSONify it using JSONify function to get the response in JSON format, and we will also return HTTP status code, which are the codes for different statuses. Since here the status is success, the HTTP code for success is 200, which states everything is okay. You can search for HTTP status codes and learn more if you like. Okay, so here we have successfully created our first function to interact with our blockchain. Now let's test it in the Thunder Client. First, let's run our web app. For that, if you see here on documentation, we need to type flux --- app, name of the file, I have blockchain, then run. This will start our application. It says running on this URL. All good. Now let's go to the Thunder client. And here choose the get method, and in the URL field, copy the URL on which our app is running. And if you remember, we have given route for mine block as /mine_block. So to access the mine block function, we need this whole URL. Alright, method get and URL is fine. Now let's click on send button. Oh, we have the response displayed that we have justified. You can see the index2 message as congratulations, you have mined a block, previous hash, proof and timestamp. Hooray! So we have successfully implemented our first function and interact with the blockchain. If you wonder here how this block was mined and created, we have a Genesis block at index1 which we have created. If you see here, we have given proof as 1 and previous hash 0. This will create the first block, that is Genesis block, with the help of this create block function, and it will append this block to the chain list. Now when we click on send button here, what it does is it calls this function that we have defined on the route. Since we already have previous block for this, that is Genesis block, it will get the previous block, previous proof and previous hash. Then it generates proof for this block. Now since it has proof and previous hash, it can find the proof of work and create new block. So this is what we are seeing in this response, the new block at index2. I hope you have understood it now.